Welcome to Market Scale IoT. I'm your host, Sean Heath. One of the most complex and important purchases that any company can make is maintenance management software. How do you know if you're using it right? Yes, you got some training during the initial purchase and installation, but are you really using every tip, trick, and feature in that software? And the other question is, did we integrate it correctly into the control system that we already have? I do not know all the answers to those questions. My guest on the podcast today does, and that's Steve Reed, Vice President of Safety and Engineering at CASA Company. Steve, how are you today?
Good morning, Sean. I'm doing great, thank you.
Are CMMS usually fully utilized?
Absolutely not. Like a lot of software packages, what people do is get accustomed to using certain features within them, and they become very familiar with those, but there's other capabilities within those tools that they don't necessarily use, and so absolutely not.
I'm very familiar with the popcorn button on my microwave. I'm not really familiar with almost anything else that a microwave can do. Is that a proper analogy?
Yes, it is.
Moving from that issue, which is that's a big deal. What are a few ways that a customer can improve the way they get the most functionality out of their system?
So it's important for customers to users of these CMM systems, Computerized Maintenance Management Systems. It's important for them to understand which features add value to them. And maybe the popcorn button is the only thing that is valuable for you, but the reality is there's lots of different possibilities, and until you really understand all of those and eliminate the ones that don't add value, you may be leaving some opportunities on the table. And so for most maintenance management systems, it's important to go back once in a while and sit down with that supplier and go back through and see show me some of these other tools, show me some of these other features that maybe we've had some process changes, maybe we've had some people changes, maybe we've had different equipment involved. And so what other features are available now that we may be able to use?
Most customers don't use every feature in a piece of software when they first buy it.
Correct.
One of the challenges in learning those new features is just how well the integration with the existing systems was. Is that something that's easily managed?
Yes, it is. If it takes energy, it takes thought and planning ahead of time. But most facilities that use CMM software also have some sort of control system controlling their processes on the plant floor itself. They may be programmable logic controllers or PLCs controlling individual machines or a series of machines or processes to make the product that they produce in that facility. And so but typically those are a standalone system. And the CMM software is also a standalone system. But if customers were to look at those two independent things and dovetail the pieces that make sense together into one integrated system, again, you aren't necessarily going to use every feature in the CMM software that is available, but go through that list and see which ones make sense and which ones make sense to integrate or get information automatically from the control system into that CMM system to enhance or make your CMM software even more usable.
Systematic failure is the nightmare of any plant, any production facility. When you put in a CMM, is it possible to tweak that or use it to either help minimize or, even predict a failure before it happens?
Well, in and of itself, it's difficult to do that with just the CMM software itself, because typically what you do is, for example, if you have the number of hours that a motor runs, maybe it's a very critical motor within your process, and that has a certain amount of runtime. After a certain amount of hours, you want to do maintenance, preventive maintenance. So you can set that up within the CMM software to schedule that automatically, maybe once a week or once a month or once every 6 months. It automatically sends reminders in a work order for people to go out and perform regular preventive maintenance on that machine or that piece of equipment. The reality is, in the control system, it has the exact number of hours, actual hours of runtime on that piece of equipment or that motor. What if it were to feed that number back into the CMM software, so now you're doing preventive maintenance at the right time, not just based on a calendar. A good analogy in that is that in modern automobiles today, it used to be that you change your oil every 3,000 miles, and you just automatically did it every 3,000 miles. Well, modern vehicles today have indicators and sensors inside of the motor that tell you that actually monitor the driving conditions. Maybe there's a lot of stop and go. Maybe there's a lot of mountain driving or heavy towing use. Maybe the oil breaks down sooner, or the opposite. Maybe it's not broken down. So you don't have to change it as frequently because the oil itself is still useful. You're saving money by using those systems to not automatically change the oil before it's actually needs to be changed. Well, you can do the same kind of thing with the CMM software integrated into your control system by reading the information that's actually happening on the plant floor directly into the CMM, and then do your preventive maintenance scheduling and parts replacement, things like that, based on the actual wear and tear, the actual usage of the equipment versus based on a date on a calendar.
3,000 miles that I drive in a car, probably not the same style of 3,000 miles that you drive in a car.
Correct.
And how finite can these measuring systems get? I mean, how really finicky can you make one of these systems?
So another good example might be you can easily monitor the vibration of a bearing. As a bearing wears over time, eventually it starts to vibrate. It's subtle in that you can't tell it. If you put your hand on the bearing itself, you can't feel it. But the reality is it is vibrating more and more and more over time. And so by monitoring the vibration over time with the control system, and then looking at the differences from when it was new or when it was slightly used to over time, once that vibration gets outside of a certain window or parameter, then you can alarm that automatically from the control system into the CMM software to set up a preventive maintenance or predictive maintenance scheduling event, so that the maintenance people can go out there and look at it ahead of time before the bearing fails.
We've called this IoT, so let's get digital for just a moment. What trend have you seen recently with operator interface terminals that really has caught your eye?
The operator interface terminals historically were a computer or a terminal monitor bolted to a control panel, and like a big anchor, like a big heavy weight. But with the IoT, with the Internet of Things and the mobility of pads, tablets, cell phones, smartphones, all of those operator interface terminals now, or OITs, can easily be integrated into those mobile devices. And they can be customized specifically for whoever the audience is or the owner of that mobile device. So maybe that the information that's coming from the vibration on that bearing, maybe it needs to go to the maintenance people. And at some point, if that's not responded to, or if it's escalated, maybe it's not only vibrating, but it's also very hot to a dangerous level. Maybe that also goes to engineering or to supervisory level to get more and more people's attention on solving this problem or fixing it before the bearing actually fails and shutting down production.
And it seems like the ability to have the system report its own health, that seems very logical. Is that a relatively new occurrence?
It's actually not. And it's like the popcorn button. It's one of those features that has been available for some time, but people don't necessarily know about it or utilize it to the extent that they can manage their predictive maintenance, so that they're solving problems. They're making sure that the uptime or the equipment availability time is as high as possible. There's many, many different business metrics that people measure, one of the most productive that I've seen is uptime on equipment. And if you do your predictive maintenance reliably and accurately by integrating the control system into your CMM, you can easily predict these imminent failures well in advance and have the right parts available. Maybe some of these parts take time to receive from the vendor. Maybe you have to schedule production downtime in order to shut the equipment down for the time that it takes to replace some of these parts. You can manage that in a smart way before it's an emergency and you're changing things on the fly.
And the cost of one of these systems is pennies compared to the actual potential lost revenue for a big breakdown.
Oh, absolutely. That's a great point, because many CMM systems are $50 to $250 a month. They have a regular maintenance fee, regular recurring fee on them, because most of the data is kept online or on the cloud. So they have to manage that data. So there's a recurring fee associated with that. But if you look at the overall cost of that, the return on investment on that over time, it's pennies in the grand scheme of things compared to a shutdown of a day or a week of production, because you didn't predict these issues, these imminent failures ahead of time, and get it taken care of in a timely manner.
Obviously, these are very intricate, very complex systems, but what's something simple that would surprise people most about the industry?
I think that what it actually takes to integrate these systems is not as complex as what it once was. The way these different computerized systems, whether they be the control system on the plant floor or the CMM software itself, with latest technologies available, what it takes to actually integrate those together is relatively easy, relatively simple. And sure, it's going to take some computer people, computer programming, it's going to take some technical people to make that happen. But those people are accustomed to doing integrating those type of systems today. Another piece in that is to integrate potentially the CMM software with the supply chain software, such that if you need a predictive maintenance event was generated because the PLC on the plant floor, the control system on the plant floor said, hey, failure is imminent. That got sent to the CMM software. The CMM software is automatically set up to, okay, because of that, I'm going to need the following parts in order to do that maintenance. And it sends that list automatically to the supply chain or to the purchasing people. They get those parts on order. They come in, they're sitting there ready to go for the scheduled event of replacing these components in a predictive way rather than in an emergency.
It has been my pleasure today to have a conversation with Steve Reed, the Vice President of Safety and Engineering at CASA Companies. Steve, thanks again. This was really, really kind of you. I really do appreciate it.
Thank you, Sean, and have a great day.